Hey everyone, in this video about the APC, we're going to talk about how to find the center of mass of an object. Now the AP1 does sort of cover the center of mass stuff, but it doesn't go into as much detail. For the most part, it's just more hand-waved and general concepts. We're going to go into much more detail. So in particular, we're going to figure out actually how to find the center of mass for uniform objects, for non-uniform objects in one dimension, and non-uniform objects in two dimensions. Now, the uniform objects is actually really easy. Uniform objects means that the mass is evenly distributed along the object. Um, so the center mass will always be directed in the middle. So if we had a ruler, let's say, then the center mass is in the middle. But this also works for a system of objects, like two people on a seesaw. In this case, if we have two identical people on the seesaw, the center mass would be right there in the middle. Or better yet, if we had two planets or two stars of equal mass, the center of mass would be directly in the middle. Now, what about non-uniform objects? Well, just like with the AP1, you should have an idea that the center of mass generally will be located closer to the heavier object. That's pretty much the extent that the AP1 cares about. So if we have a baseball bat, one end is thicker and bigger and heavier than the other end, so it makes sense that the center of mass wouldn't be in the middle, but more towards that side. Same thing about two people on the seesaw; it should be closer to the bigger person. Nothing crazy there. Now, what if we want to find the specific location? Well, in case you want to do this at home or in a lab setup, you actually could find it if you had a physical object by hanging the object from two different points and then drawing a line going straight down. So here you hang this object from one point, you let it uh, freely hang from that point. You draw a line going straight down. Then what you can do is hang it from a new point, draw a line going straight down from there. And the point where those two lines intersect will be where the center of mass is. Ideally, you probably would want to do a third line just to make sure that that's the correct point. Of course, on the exam, you won't have a physical object to work with, so how do we use math to find the center? Well, the equation for the center of mass is given by this. This term represents the position of the center of mass, that's what this says, and that's going to be equal to the sum of the parts of mass times position divided by the total mass. So basically, this is saying that we're taking the value of each mass and multiplying it by the location of each mass, taking that into account for the entire system, and then dividing it by the total mass. Now, this equation is going to be confusing just looking at it, so let's actually do a practice problem. Let's consider we had a case like this. We have two balls here. One is 6 kilograms and one's 3 kilograms, separated by 5 meters, and I want to know where's the center of mass of this system. And we're going to consider from the 6 kilogram ball. Now, first thing I want to do is pick a point. This point's going to be acting as our origin, where we're going to be measuring our distances from. Now, it doesn't really matter where you put it, but you kind of want, because it's supposed to be your reference point, you kind of want to make sure you make life easy. And my recommendation is you pretend like you're going to put this on a graph, like an X and Y graph, and you want to make it so that the diagram is always in the first quadrant. So what I mean is the very bottom left of your scenario should be where your zero line is. So in this case, this is my graph. This section is my, quadrant one of the graph. I want to make it so that our diagram is right here. I technically could put the origin point as 0.1, let's say, or directly in the middle at 2.5, so that each one is 2.5 meters away from it. However, one thing that you'd have to be careful for is that if you do that, while this mass is 2.5 away, this mass is negative 2.5 away. So that's why you kind of want to make it so that you're as far left and far down as possible so that every distance is positive. Once you pick your point, what you're going to do is find the distance of each mass from that reference point. Now, this reference point is being placed in the very middle of the 6 kilogram object. Because remember, all this other mass doesn't matter. All that matters is where the center is. So 6 kilogram mass is 0 meters from my reference point. The 3 kilogram mass, on the other hand, is the full 5 meters away. So we have our mass and our positions. Step 3 is I'm going to take these numbers and multiply them, and then I'm going to add them all up. So we had the 6 kilogram mass was 0 meters away, we had the 3 kilogram mass was 5 meters away. So we get 0 plus 15, which gets me 15. Step 4, we're then going to divide this number by the total mass. So this is where the denominator was. So the total mass was 6 and 3, which gets us 9. Bringing this all together, we end up getting this, that the location of the center of mass is 1.67 meters from our origin. Because our origin was where the 6 kilogram mass is, we can also say that this is 1.67 meters from the center of the 6 kilogram object. All right, so that's how to find the center of mass when we have an object in a one-dimensional setup. And it's nothing crazy. If we had 5 more objects, we would just keep doing the same thing, at multiplying the masses in position, adding them all up, divided by the total, easy peasy. Now let's talk about, well, what if the object's in 2 dimensions? Now, what I mean by that is there's a few different ways of doing this. Let's say we had a scenario like this where we had a ruler or a wire that was bent at a bunch of corners so that it kind of encompassed both the x and y direction. It could also just be objects oriented in a two-dimensional shape like a triangle, and we're being asked, well, where's the center of mass? Now, we end up doing the same steps as before, but this time the center mass isn't just x, it's x and y. So what we're going to have to do is separate and do it almost twice, once for the x direction and once for the y direction. Now, it would be annoying to have to go through the x direction first and then just repeat it for the y. So instead, we're gonna kind of do it simultaneously. And when we find the positions, we're more gonna find the coordinates of the x and y. Now, one thing I want to note is that in this picture, they kind of already have the origin in the bottom left hand, but this is what this diagram kind of shows it, as what I'm trying to say is that this shape is all in this first quadrant. There's nothing over in this section. There's nothing to the left of y, and there's nothing below the x-axis. Now, we go through the same steps. First step, we're going to pick this bottom left-hand corner to be our origin. Like I said, it's already shown to us like that in our diagram. So, we don't actually have to spend too much time on that thought. But the second step, where we find the position of the masses, the distances of the masses, what we're going to do is we're going to find the coordinates of each of these segments. And we're going to actually treat each of these segments as if they're separate wires where all their mass is located in the middle, because the question didn't explicitly say it. I kind of made a mistake with that. But this is supposed to be a uniform mass wire. So along the wire, it has its mass is evenly distributed. So this wire, and this segment, and this right segment all have the same mass. This segment, which is half the length, has half the mass. So we end up having our 3 segments, the green, the purple, the red, that all have the same mass of m, and we have the yellow segment as half m. Now, if you actually don't want to deal with the half, you could have made this be 2m, 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 and m, whatever, as long as you have that this mass is half of these 3 masses. Notice that this is just a placeholder. It doesn't really matter. It's going to end up dropping out in the end anyway. Now, for the coordinates, like I said, the center of mass of each of these segments, or the mass, is located in the center of each of these segments. So this segment goes from 0 to 2. So the center of mass will be at 1. So we write it as 0, comma 1, because it's 0 on the x, 1 on the y. The purple segment has it right here. Again, this segment goes from 0 to 2. So the mass is right in the middle at 1. So 1 on the x, 0 on the y. So 1 comma 0. Red is over here, again, right in the middle. So I have to go all the way to 2 in order to get to that segment on the x-axis, and I go up to 1 on the y-axis. And then up here is a little bit harder to do. I have to go all the way up. The y coordinate is going to be 2. The x coordinate is going to be 1.5, because it's going to be halfway along here. That's 1, and then it's a half. There we go. So this coordinate will be 1.5, comma 2. Now, we're going to do step 3. Now, remember, step 3 is 2 parts. We have to multiply the mass with their position values, and then we're going to add them up. And we're going to make sure when we add them up, we keep the x's and y's separate. So I basically just multiply m and x and m and y for all these. So this becomes 0 comma m instead of 0 comma 1, m comma 0, 2m comma m, and 3 quarters m comma m. We're going to deal with some fractions. It's going to make it a little bit messier. All right, so now that I have all these, I'm now looking at only the x's and y's separately. I'm going to add them all up. So 0 plus m plus 2m plus 3 quarters m gets us 3.75m. And looking at the y, m plus 0 plus m gets me 3m. So this is the sum of my mx's. This is the sum of the my's. The last step is to divide each of these segments by the total mass. Now, like I said, based off of my the way I wrote this segment has a mass of m, this has a mass of m, this is a mass of m because they're all the same length, and this is half m because it's half the length. So that tells me that the total mass is 3.5. Putting this all together, we get that the position of the x coordinate is 1.07, and the position of the y coordinate is 0.86. So our center of mass is going to be located at 1.07 comma 0.86. So right about over here, a little bit past this one mark and a little bit below the green and red marks are. All right. And that's it. That's all you have to do for the 2 dimensions. It's just like the 1 dimension, just with the extra step of doing coordinates instead of single positions and making sure that you keep x and y separate. But nothing crazy. Again, you do want to make sure that you practice a few other examples of this just so you have a little bit